All right, today in geometry, we are looking at section 9.7, dilations. As always, we will start out with the vocabulary. So a dilation is a transformation that stretches or shrinks a figure to create a similar figure. A figure is enlarged or reduced with respect to a fixed point called the center of dilation. The scale factor of a dilation is the ratio of a side length to the corresponding side length of the original figure. Remember that corresponding means sits in the same spot. In the figure shown, triangle XYZ is the image of triangle ABC. The center of dilation is 0, 0, and the scale factor would be, so my image goes first, so if I took side XY is where I'm going to start. So I would say XY over, I need that exact same side, so the corresponding side to that in the pre-image triangle, and so XY corresponds with AB. So I would find the scale factor by putting XY over AB. So I always put the image over the pre-image. You can describe a dilation with respect to the origin with the following notation. So if I started out with the point x comma y, then I went to the point k times x comma k times y, where k is my scale factor. If k is between the numbers 0 and 1, so if it's smaller than 1 but bigger than 0, the dilation is a reduction. If k is greater than 1, the dilation is an enlargement. So if k is greater than 1, it got bigger. If it's between 0 and 1, it got smaller. If k is exactly 1, then it didn't change size at all. It's not a dilation. All right, a dilation with center C and scale factor K maps every point P in a figure to a point P prime so that one of the following is true. And now we're looking at this picture, okay? So number one, if P is not the center point, C, okay? So P is not the center point C. So the image P prime lies on the line C to P, or the ray C to P. The scale factor K is a positive number such that, again, to find that K, it would be CP prime over CP. So again, it's the image over the pre-image, and K cannot equal 1. Or if P is the center point C, then P is equal to P prime. So just like our lines of reflection, if the point is on the line of reflection, then the pre-image and the image are the same thing. So here, again, if P is the center point, then P and P prime are going to be the same. All right, so two things that we need to be able to do. First, we want to identify a dilation. So find the scale factor of the dilation, then tell if the dilation is a reduction or an enlargement. Again, what we have to remember to find our scale factor is the image over the pre-image. Okay? So image over the pre-image. So in this picture, I have a C, a P, and a P prime. So I'm going to do C, P prime, because that's going to be my image over my pre-image C to P. So the entire length, they tell me, is 12. So I'm going to have 12 over, just from C to P is 8. And as always, since I can reduce 12 and 8, I need to do that. So 12 and 8 both have a 4 in common. So this reduces to 3/2. So my scale factor, or my K, is 3/2. So now I have to tell if this is a reduction or an enlargement. Remember, if K is greater than 1, it's an enlargement. If it's between 0 and 1, it's a reduction. Well, 3/2 is definitely bigger than 1, so this would have been an enlargement. So we will try that again. So on this next one, again, I have a C, a P prime, and a P. So again, I'm going to do C, P prime over CP. So this time, CP prime is from here to here is 18. So I get 18 over C to P is 30. So 18 over 30, again, I can reduce that. 18 and 30 both have a 6 in common. So 6 goes in 18 3 times, 6 goes in 30 5 times. So here, my K is 3/5. Now I need to identify that as a reduction or an enlargement. 3/5 is smaller than 1, so that would be a reduction. So that's all there is to finding the scale factor and then determining if it's enlargement or reduction. And just remember that the scale factor is always the image over the pre-image and it's corresponding. And then we reduce it. If that number is greater than 1, it's an enlargement. If it's between 0 and 1, it's a reduction. All right, so now we're going to find the image of a composition. So it tells us the vertices of triangle ABC are at A, -4, 1, B, -2, 2, and C, -2, 1. Find the image of triangle ABC after the given composition. We want a translation of x plus 5, comma, y plus 1, then a dilation centered at the origin with a scale factor of 2. Since this is not written as the composition with the open dot, I'm going to go ahead and just do the order that they give to me. Okay, so I'm just going to write down my A, B, and C again over here. So A is at -4, 1. B is at -2, 2. And C is at -2, 1. So we're going to do a translation of x plus 5 and y plus 1. And that's going to give me A prime, B prime, and C prime. So I want to add 5 to all of my x's. Okay? So -4 plus 5 is going to get me at 1. And then I'm going to add 1 to my y's. So 1 plus 1 gets me a 2. So A prime is the point 1, 2. So if I go back to B and I do -2 plus 5, I get 3. 2 plus 1 gets me 3. So B prime is at 3, 3. I go back to C, -2 plus 5 is 3. 1 plus 1 is 2. So C prime is 3, 2. So now I want to do the dilation, right? The scale factor of 2. So that means that my K is equal to 2. Remember that we had that at the very beginning where it said x comma y goes to kx comma ky. So here my k is 2. So really what I'm doing is 2x comma 2y. So that's going to get me A double prime, B double prime, and C double prime. So I'm going back to A prime now. So x was 1. I need to multiply that by 2. So 2 times 1 is 2. I multiply y by 2. 2 times 2 is 4. Now I go to B prime. 3 times 2 is 6. 3 times 2 is 6. So B prime is 6, 6. C prime, multiply both of these by 2. So 3 times 2 is 6. 2 times 2 is 4. So that is the new image after both of these. I can go ahead and graph all three so that I can see what they look like. So if I first do the A, B, and C, so -4, 1. There was my A. -2, 2. There was B. -2, 1. So that was triangle ABC to begin with. I'll switch colors, and now I'll do A prime, B prime, C prime. So 1, 2 is A prime. 3, 3 was B prime. And 3, 2 was C prime. And so now we'll do the very last one, our double prime. So 2, 4 is A double prime. 6, 6 was B double prime. And 6, 4, C double prime. So the blue one is the new one. My blue triangle definitely looks bigger than my red triangle, so I would say that this is an enlargement by my graph, and I can check myself on that because remember they told me my scale factor was 2. A scale factor bigger than 1 means an enlargement. So yes, my triangle should have gotten bigger at the end after I did the dilation. And that is all that we need to look at for section 9.7 dilations. So your homework will be 9.7 worksheet. There will be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 questions. Okay, so get started on that homework. Again, remember that these notes will be filled out on Canvas so that you can go back and look at that at any time or watch the video on your own at any time.